Hi students, if you missed our Zoom meeting today or if you were having technology problems, I wanted to post this video so that you could have the answers to the practice problems that we went over during the meeting today. So it was this morning, I posted this announcement, and what we're going to start doing in our Zoom meetings is I'm going to include some practice problems. So from the announcement, you could have pulled up the practice problems and printed them out if you want to. You don't have to print them. I'm also adding them to the modules each week, so it's there if you want to pause this video and print it so you have it to follow along. You can do that. Like I said, you don't have to print it. You can just use a sheet of scratch paper and follow along from the screen if you want to. So if you pull it up, this is what you're going to see. It's just 5 problems that we practiced really quick in the Zoom meeting. They'll help you on your quiz if you haven't taken your quiz yet. And these are problems that are similar to some that we did in class back before spring break too, so they might look familiar to you. So hopefully you watched the videos from earlier in the week that were supposed to give you your initial instruction, and I reviewed the different types of relationships that you might see in tables, graphs, and equations. So we have multiplicative relationships and additive relationships. So this first question is asking, which one is showing a multiplicative relationship? So I know you guys can figure that out. That's one where we're going to be multiplying a number. So if we look at these answer choices here, the first one says there are 3 more apples than oranges. Most of us would pick up on this really fast. If I'm saying give me 3 more, I'm adding 3 to the total. So that would be an additive relationship. B is just saying there is a total of 9 bananas. Okay, there's no math going on there. They're just telling us there's 9 bananas. That's it. We're not adding, we're not multiplying. So that's definitely not a multiplicative relationship. C, there are 8 times as many grapes as oranges. Most of you would pick up on this one pretty quick. Times goes with multiplication. So we would be doing 8 times the number. And then D is a lot like B. It's just a statement. There's no math going on there. So C is our choice for sure on that one. Okay, this next one is a table. There's one very similar to this on your quiz this week. We have a person who has this amount of money at the beginning of the day. Then they buy lunch and they have a certain amount left over. So we're looking for a pattern here. This is what he starts with. This is what he has after lunch. So how is our number changing from before lunch to after lunch? We should be able to tell our numbers are definitely getting smaller. Remember, with our tables, X is always on the left. So this would be our X value. They're calling it M, but it's the same thing. And this would be our Y value. So this is our input. This is what we start with. This is what we end up with, our output. So our input numbers are larger than our output numbers each time. So what that should tell us is we're either subtracting to get the smaller number, or we are multiplying by a number less than 1, which would be a fraction or a decimal with a value less than 1. Easiest thing to look at probably is subtraction. So to do that, $14.75 minus what number would give me $12.50? $8.50 minus what number would give me $6.25? You could pick any set of numbers you want, whatever looks easiest to you, but I would set up a quick subtraction problem and just see what is being subtracted here. So we have $14.75, we buy lunch. After that, we have $12.50 left. So to figure out the change, we can quickly subtract. And remember, if you're adding and subtracting with decimals, you do have to line up at the decimal point. And once we do that, we can see it's $2.25. So this person must be spending $2.25 on lunch, maybe, but we need to make sure that that pattern keeps going. So next I would do my second set of numbers, $8.50 minus $6.25, to make sure that that difference is also $2.25. I do have to borrow on this one, but once I do, looks good so far, and yes, it is $2.25 again. So I am spending $2.25. Now I have to set up my equation. If you look back at the notes or the videos from the beginning of the week, when we are subtracting, that's an additive relationship. Whether we're multiplying, adding, or subtracting, we always start with y first, which in this case, they're using the letter B. So I'm going to put B instead. Y is going to equal the rest of the equation. When we are adding, we always put x first, or in the case of this problem, m, and then after that we show what we are adding or subtracting. In this case, it's subtracting, so this would be the correct way to set up this equation. Now on your quiz, if you haven't taken it, it is going to be multiple choice, so that should help you. Okay, let's move on to number 3. And at any point, you can pause this and try these problems on your own. In fact, that's what I would suggest that you do. So on this one, Sue is writing an essay for social studies. The table shows the number of words she wrote at different time intervals. Which equation represents the relationship between time and minutes and the number of words, W? So again, I would start off by looking at your input and your output. Time is your input, words would be your output. They're using T and W instead of X and Y. Our numbers are growing, so we're either multiplying by something or adding something. Now in this case, they've given you these answer choices. So really, I can just go from there and look at those, and I don't have to do a whole lot of thinking. So if we're growing, we're either adding or multiplying by something. So that would eliminate choice D. We also know when we set up equations, Y should go first. So if we're looking at this table, that means W would go first in the equation, so we can get rid of choice C also. So now we just need to see, are we adding 32 or are we multiplying by 32? So if I plug in the numbers, I have a 1 and a 32. That means 1 would go right here, 32 would go here. Where W is 1 plus 32 going to give me 32? It's not. It's going to give me 33. So then we try this next one. This one, if I plug in my numbers from my table, would be 32 equals 32 times 1. That is a true statement, and we can check it with this next one as well. 32 times 3 would give me 96. So that's a good equation. That one is going to be choice B. On number 4, they want us to come up with an equation. We did some like this in our circuits in class, and I told you guys the easiest way is to make yourself a quick table when you have one like this. It's hard to look at the graph and just go straight to the equation. You'll get better at it as time goes, but I would suggest making a table. Another thing you want to look for is good points to use. Points like this that don't exactly land on grid lines are probably not the best to use. You can usually figure out what numbers go with them, but if you want to be sure, I would use the points that line up with the grid lines perfectly, like these 3 do. So now that we know which points we want to look at, we're just going to get the numbers from the table. So remember, X is your horizontal axis, and they have it labeled. So for X, we would have 2, Y would be 15, and then X is 4, Y is 30, X is 6, Y is 45. So those are my 3 points I'm going to use, and 3 points is definitely enough to figure out what's going on. So remember, X is input, Y is output. So we're starting with 2, we end up with 15, 4 to 30, 6 to 45. Our numbers are growing, which tells me I am either adding or multiplying by something. And remember, we always set up our equations with Y first. So what is happening to X to get us to Y? Well, if we look at adding, 2 plus what number would give me 15? If I don't know, sorry, that's messy. What's 15 minus 2? It's 13. So 2 plus 13 would give me 15. Then I've got to check it. If I do plus 13, is it going to work on the next one? Is 4 plus 13 going to give me 30? It's not. So that's out. We're not adding. We must be multiplying. So now I have to figure out 2 times what number gives me 15. 4 times what number would give me 30. Again, you can always work backwards. 2 times 7 is 14, 2 times 8 is 16, so it's somewhere in between that. So we can always divide 15 by 2. It's not going to go into 1. It'll go in 7 times to give me 14 with 1 left over. So I'm going to add a decimal point so I can add a 0. 2 will go into 10 twice. So it's going to be 7.5. And then again, I would want to check that. Check for your next set of data. 7.5 times 4 should give you 30 if that's what it is, and it does. So we are multiplying by 7.5. Your equation would be y equals 7.5x. Okay, and then one more problem is all we have left. So this last one, I definitely want you to pause it and try to figure it out on your own, and then you can play the video and check your work. The cost of 1 bag of Takis is $3.49. Write an equation to show T, the cost in dollars of buying N bags of Takis. When it's set up like this and you don't have a table and you don't have a graph, sometimes it's hard to tell what would be X and Y. In most cases, it's going to be multiple choice, so that will help you out. But you can also think about, what is going to determine what? Would the number of bags determine how much you're going to pay, or how much you're going to pay determine the number of bags? So this would be the independent variable, this would be the dependent variable. And hopefully remember, independent is X, dependent is Y. So when we're setting up this equation, N would be in X's place and T would be in Y's place. That means, since we always do Y equals, this is going to be a T equals equation. So T is our total cost. How do we figure that out? If each bag is $3.49, most of you already would be saying, I would multiply, Miss Mitch. But if you can't figure that out, if I bought 1 bag of Takis, how much am I going to pay? I'm going to pay $3.49. If I buy 2 bags of Takis, I'm going to pay double that amount. So it's going to be $6.98, $3.49 times 2. And I can keep going and hopefully realize that I'm multiplying the cost of 1 bag, $3.49, times the number of bags, which in this case is not X, they want us to use N. So there is your equation. That is the last practice problem that we have. Hopefully this will help you on your quiz. Remember, your quiz is multiple choice, so it should be a little bit easier than what we just did here. And you can always email me if you have any questions. Thanks for watching.